Welcome to Python Basics with EJD. This is the second video on object-oriented programming, the OOP for short. And in this video, we'll be looking at the uh, core building blocks of object-oriented programming. In the first video, we had our introduction to object-oriented programming, and we discovered that they are basically built on classes and objects. That is, object-oriented programming is built on classes and objects. So we will begin to explore that from now. So object-oriented programming building blocks like that. Okay, so the goal here is to understand how to define and use classes and objects, since these are the core building blocks of object-oriented programming. Okay, so straight up, we go for classes and objects. If a class is simply a blueprint for creating objects. So a class is a blueprint for creating objects, and it defines structure and behavior. Where we see structure, that attributes, and behavior will be like methods. So attributes are the characteristics. Attributes are the way you describe something, and behavior are the things those things something does, right? And we saw some of those examples. I think one of the examples we saw is that if you have a cat, for instance, you can say you can have attributes like whether it's black or it's a white cat, a black. So you can talk about its color, you can talk about the size and things like that. But then it also has behavior, like it makes sounds, then it's clean or things like that. So a class being a blueprint for creating objects, defining structure and behavior, or what you can call attributes and methods. On the other hand, an object is an instance of a class with actual data. So it's more like a class, as you're going to see later, right? A class is more like the architectural design of what you want to build, while the object is actually the actual thing you're building. And to define a class, right, you need a keyword class. To define a function, you need the keyword def, right? So, and we remember in naming Python variables, you cannot use any of these keywords to name a variable. So, to create any class, you need to start with the keyword class. And then once you now have a dog, this dog is now the class name, right? And of course, anytime you have an if function, or you define you have an if statement, or you have an if statement, like maybe in while loops, in for loops, and things like that, or you define a function, or you define a class, the line must end with a full colon like this, right? And then now this part now is just saying that, okay, we are defining the class and we don't want to do anything with the class right now. So if I run this code, it will not necessarily give any result because I've not told it to do anything. And for you to now call the class, so you have to copy out this dog, just like for function, you copy out this dog, and put dog open and close brackets. Now, this my dog you have here is just a variable name for the object you are calling from that class, right? So, but because this class is not doing anything, if I run it, it's not going to give any result per se. So if I say print, I say my dog is this. So if I say print my dog, it will not necessarily give any result because the function is really not doing anything like that. But it's going to give maybe the kind of class or object it is like that. Once that is done, so it takes a bit of time. The first time we go for this, but I think this is taking too long time. Hope it comes on pretty soon. Interesting. This is longer than I expected. Okay, wait patiently and see what that is about. Great. So it tells us that the dog is an object and gives some extra information. And then you can also print the type. It tells us it's a class, main dog, this is actually a class. But of course, we are going to have proper class definitions and get them to do stuff as we move on. So let's talk about the syntax. I think what I did up there is just an introduction to the whole idea. So the syntax is with the class keyword. So to define a class, like I said, you need a class keyword, right? So once we say class, we know we are defining a class, dealing with object-oriented programming. So classes are defined using the class keyword, and the naming convention is Pascal case for class names. So when you talk about Pascal case, you're talking about, the naming convention for a class. If you're talking about black car, for instance, so you have B will be capital and C will be capital. So black car with capital B and capital C. Or if you're naming something Python library, the P will be capital and the L in the library will be capital, and there's no space in between. That is what is called Pascal case. So if I'm declaring a class with my full name, Emmanuel Jason Dansu, the E, J, and D will be in capital, and there will be no space in between. So Emmanuel Jason Dansu with capital E, J, D. That's what is called Pascal case, and that is what is used for naming for class names. All right. So, but of course, if you have just one word, you just have the first letter capital, and that's all. So imagine we are defining a class car, okay? And we are so under in the class car, we now have a function under it, and the function is drive self. So we have so the name of the name of the class is car. Then we have a function under this car, which is drive and self. So this self now, of course, is the what did we call in definition of functions? We talked about this is a parameter for the function, right? And then we can then print. In fact, if you point at it in this place, it tells you a bit information. So you have self car now. All right. So, and what the function is doing inside the class is to print car is moving. Okay. So if you now say my car is equal to, if you want to call the class, you have to say car open and close bracket. So this is you calling the car here, right? But then this is you calling the car. Now, as you're calling the car, you're now giving it a variable name, my car, right? So you give it a variable name, my car, and then what you're in line 6 now. So you're basically assigning whatever the car is doing to this. But in line 6 now, you're now giving it the special, you're calling the drive function inside the car class so that we expect this now to print car is moving. And we'll just print this and it says that. So if I use alternate enter, it creates a new cell automatically. Now I want to demonstrate that instead of having to say my car, my underscore car equals car, I could just as well come straight and say car. I want to try this out. Say car dot drive. I think okay, maybe it also needs a box in front. Yeah, so that does the same job. So you don't always have to give it a variable name. You can just go straight, call the car function and call a function under it, just like I've done. So it gives you exactly the same result. Okay, so let's talk about the concept of a blueprint. The other time we said that a class is like an architect's blueprint. It tells you what the house is going to look like. One object is actually objects are the houses built themselves. So class is my architectural plan, while objects are the actual houses or whatever structures are built. So a class is an architect's blueprints, while objects are the houses built. Each has its own data space. So in this case now, an object is a specific instance of a class, basically, if that is okay. So imagine that we have a function, a class rather, we define a class house, okay? So if you want to call this class now, you just say house, open and close bracket. That's how to call that. All right. Then you now have a function which initializes the class. So with self color, so you see self here now. So self is a parameter, color is also a parameter. That's any color at all. Then self here is self at house, right? Then if you now under this now, you now have self dot color. Now, so if you now have house 1, so we can now have different house. So this class is the master plan. Then you can now use that plan to build all kinds of houses. You can build 50 houses and paint them different colors. Let's say you have house 1, which you call, the other time when we called it, we didn't have anything here because color was not defined, but here color is defined. So we can now specify for house 1, we wanted to, using the plan called house, we have it, we print it red. House 2, we print that blue. So if you now want to call that, then you have print h1 dot color or print h2 dot color, and you get your red or blue like that. So based on what you have specified. Now, if you want to do what I did the other time, and you don't want to give it variable names, like I said, again, I'm using alternate enter so it can create a new cell for me. So all you just need to do is call the house function. It's more like copy this out. That's the class name, just like we did for functions. So once you copy that and paste it here, then you can now say house now. Okay, of course, with this house, okay, dot, then you can now okay, let's even do ordinary house. We do house dot color, okay, house dot color like this. So it requires position, argument, color. So the reason is because it requires a position, argument, color, because self.color is color. So we need a specific color to get that running. So what if we want a purple house? If there's anything like that. So if oh, okay, what's happening here? So this is string object is not callable. Why? But it was callable here. Okay, let's go again. Uh, print. Do I have to print this? Print. Oh, still giving issues. Why is it not callable? Okay, so it means that it's better to stick with what we had up here, right? So it's better you rename it and then you can now call the color in each situation. All right. So that way we have those different colors. So I can get off with this. Okay. So I mean, one way you learn when you're learning Python or any programming languages, try things out and see what works and see what doesn't work, and then that way you keep learning. So creating objects and using attributes, right? So attributes are actually variables inside a class. Just like that color we talked about here now. So this color here now is an attribute. Then that self, you are going to find out what exactly it is about. So we are going step by step. So creating objects and using attributes. So attributes are variables inside a class. So access attributes using object.attribute. So if you want to see the attributes of a particular class, use object.attributes, right? So in this case now, you have a class called person, and the person has two attributes. The person has a name, the person has an attribute, and this self now, we are going to learn about the self. When we get there, we'll talk about it. So you have self.name equals name, self.age equals age. So this self seems to be what an iterator used to be in the case of iterables. When you have like a string and then you now say for I in this string, print I. So this self now is like that kind of thing for a class. That's the best explanation I have for that right now. So imagine now person one. Person one is Alice, and Alice is 25. So if it's because these are the two attributes we are talking about now, name and age, right? So if you now print p1.name, it gives Alice, p1.age, it gives the age, which is 25. So what if you now create person two? I do alternate enter, create a new cell. I now have person two, and for that person two now, of course, that space is not necessary. I just did that. Oh, okay. It has even given me some options. So I just accept everything by pressing tab. Okay. So person two is Bob, and oh, this Alice and Bob thing always. Okay, that's fine. But let me change it now to say Bonu. All right, let's do Bonu. Right. So person two is Bonu and Bonu is 30. So if you print person two name, it gives you Bonu. If you print person three age, it gives you 30, just like we had before. So you need attributes. You can use attributes like that. So we've seen cases where there was no attributes at all, like in the case of this dog, we can even declare a class we don't use. And here, there's really no attributes, but then we have a function doing something inside the class. That's what we have in that situation. And then we talked about the concept of a blueprint where we had one attribute, color. The self is not an attribute per se, so you're going to find out later. Then let's talk about instance variables versus local variables, right? So at one of the videos I did in this series is about um variable scopes in Python, and then we saw the legb construct talking about local variables. Then we go on to, I think, what's that now? I've forgotten what that e is. Then there's a particular e thing like that, and then we go ahead to group. No, is it group now? Then we have a g. I've forgotten the g also. We have g, global variables, exactly, and then we now have b, which are built-in variables. I think E variables are they external variables or something like that? That's like when you have an outer and inner thing in a function, so you have those levels of variables like that. Okay. So instance variables belong to objects, and they are declared with self. Okay. So self is like what points to that variable. Self is that thing that points to the to the stuff. So you declare instance variable using self, but then you have local variables which exist only inside a method, right? So imagine that you have a class a class called test, and you initialize the class. You say self dot by x. So x now is the instance. X is the attribute, right? And then by the time you say self dot instance underscore var, that is x. So that's the instance variable. Then if you now define a method, so you discover that anytime you define a class, most of the times you have to define methods under the class to get it working. So you see the other when we did that procedural calculator in the previous video, you saw we're just defining plenty functions. But here now we have a class with some functions under it, grouping everything together, right? So we define self.instance underscore var, that is our x in this case, which is the instance variable, and then you define the method self, and here now the local. So if you now define a local variable and call it 10, this 10 now is local to this method, to this function you have defined here, which is called a method in this case. So what this method does is to print the local variable. So if you now go ahead and say and test and do test 5, okay, you say test 5, t is test 5, this is a variable name. So you see the class name is test. So if you now say test 5 and you say print t dot instance variable, now it is going to print 5 for you. You know, that's like what x becomes automatically. Then if you now say t dot method, so it prints whatever the method is supposed to do for you, which is, so you retrieve the 5 from the instance and you retrieve the method, the 10 from the method, because those are where they are localized like that. Okay. So that may be a bit tricky. Should I try? Okay. So you can actually, so just like that has been done. Okay, let me try another situation. So let's say we now have Q. Let's say Q is equal to, okay, wow, this has this is one of the benefits of Google Colab. It gives you, it's like it's thinking what you're thinking, right? So imagine that you now want to you do test 10 and you say print Q instance var. So instance var now, because I have made 10 here. Okay, maybe I should make it something else so that it doesn't conflict. So let me just say this is 23. So the instance in this case is 23. So because this 23 automatically represents this X. That is that is your instance variable. But if you are calling the method, right, it prints 10 for you. So if you run this now, you get 23 by 10. So you can just try it out so you understand. Now, using self, I've been talking about this self since. So we've been seeing self. You discover that and we saw already that you use self to declare instance variables, right? Those are variables that belong to the objects, right? So using self simply refers to the current object. That is the instance, and that's why you can use it to declare a situation, a particular a peculiarity of the class, which is the object, right? So using self refers to the current object, and it is required in instance methods, right? So we've seen this before, and we see like we saw up here that you use self to declare an instance variable. So you have the same kind of thing here. Using self now, it refers to the current object, and it is required in instance methods. Okay. So imagine you define a class animal and then you initialize it. So the initialization is with double underscore init, double underscore, and then you have the self, which is what we use to declare the instance variable, and the variable here now is name, right? So we have only one, which is name. So you can now say self.name is equal to name, easy, and then you define a function under that, which is speak. Speak now takes so speak now takes this self here, so that you can now print self.name makes a sound. All right, so any sound you want it to make. So in this case now, I mean any name you now put. So you see animal. So to call this function, so you can just say A is equal to animal, right? So you copy the animal, open and close brackets, and you specify the particular animal in this case. So here we say it's dog, and then you can now say A dot speak, right? When you say A dot speak, speak is the function right here. So you can now say dog makes a sound easily. Okay. So we can create a new cell, of course, and say B now is equal to, okay, interesting. So it has given us, so it says B is animal, and now we specify the animal to be cat, and say with B dot speak, and it says cat makes a sound. So you can keep changing like that. So once you create the class, you can then begin to have many objects of the class, right? So Then we have the init constructor method. So you'll be seeing this init all along, right? We've been seeing this init. What does it really do? That's what this next cell is about. The init constructor method, it's a special method called automatically when an object is created. So when you create an object, the init constructor method has to follow it because it is used to initialize attributes. So you use it to initialize the attributes of your class, right? So if you imagine you have a class student, then you initialize the attributes. Then, of course, using this self, the actual attributes are name and grade. So that self.name is equal to name and self.grade is equal to grade. So you can now call a particular instance of the class student, an object of that class. So you say S is student, then you say Alice, okay, and the grade for Alice is A. Then you can print S name S grade and it gives you Alice and Alice's grade. So we can create a new cell and just try something out. Then we say P is a student. So it's more like you're copying. Okay, well, it's doing that for us somehow. Okay, I think I enjoy that actually. So, okay, Bob again is here. Okay, good, let's go for that. I'll just press tab and accept that. Then it prints Bob. The grade for Bob is B. Now, the question is, why does initialization matter? Why do we have to use the init construct? The first thing is that it ensures each object starts with valid data, right? And it prevents uninitialized attributes. So initialization is necessary because you need it. It's more like you have a plan when call the class, right? So for if you want to build a house, you must have measurements. You need to have measures so that everybody that wants to build will follow that plan. But if you don't have any measures, anybody can just come and do anything and mess things up like that. So initialization really matters, right? So imagine you're creating a class product and then you do the initialization. And then you have the initials here, name and price. So here we say price is equal to 0. I think that reminds me of the idea of default values, right? Default values for parameters. So in this case, now you have self.name is name, self.price is price. Now, definitely we know that if we don't specify the price, it is going to say the price is 0. All right. So imagine we have a product called P1. So we have a product laptop, and the price of laptop is 1,200. And then we have a product uh, P2, which is book. So this book now, we don't have the price. So if you don't have the price, then it means the price is 0 because we have 0 by default. That kind of defaulting we do with functions in a video under Python functions, right? So if we run this now and we do P1 name, comma P1 price, it gives us laptop and 120. If we do P2 name and P2 price, it gives us book and the price is 0. Okay, so it means the book is for free. So if I create a new cell and I try to do maybe like P3 equals something, okay? If I do P3 equals something, okay, it gives me this. And I try to even do, okay, I have to specify. Then P4, all right? If I also do P4 is equal to, okay, yeah, it's doing that too. Nice. So we have, let's now say we have P4, P3 is, let me even run this and see what happens. I suspect there's going to be an issue. Okay, let me just run this. Yeah, there's an issue because I need to specify something for the first one. So imagine I have P3 to be, say, let's just say this is mattress. Okay, let's say mattress. I don't specify the price. And then we have this now, and the price is phone, right? And we say it's 1,000, or let's even say it's 989, right? So in this case now, I did not specify the price for mattress. So the automatic price is going to be 0. It will print mattress, price is 0. And the for phone, it will print phone and price is 989. Basically, that's what that is. So by declaring price equals 0 here, so that's more like if you don't specify price, that's the automatic price. So maybe you have a store and you have some products like that that you give away for free. So you can just do that. So anything you don't attach a price to, let it go for 0 or let it go for 10 or whatever units of money you want to declare as a default. So that's what we've used up there. And this is leading us to that point, default versus parameterized constructors. So default constructors need no arguments, while parameterized constructor takes arguments. So as you can see up there, price is a default parameter, and if you don't specify price, you don't, it automatically takes what you have. So imagine again, we define a class book and we initialize, and we have a title and it is called untitled. So if you give it a title, it will take the title you give it. If you don't give it a title, it automatically take untitled. So you now have self.title equals title. So you have book one, B1 is book one, that's default. So it gives you the default, which is untitled. Then you have B2, which is book. And then instead of, this one has only one argument. So you give it Python 1 and then it is parameterized. So that's the parameterized because you supply a particular parameter. So this is it. So that's the idea of the default constructor and the parameterized constructor. If you run this now, you have untitled for book one, and you have Python 101 for book two. Okay. So if I press enter and run this now, and I have book three, all right, and this is equal to okay, let me accept this first. So book three, and I want book three to be Python basics, okay, with EJD. That's my book three. And then I also have book four. Okay, so book four, I just want it to be okay. Book four is Java basics. Okay, let me accept that. Okay, let me accept that. I want book five now. Book five, okay, is equal to book and no, so I leave it default, right? So if I run this now, so I have three books now. Book three, Python basics with EJD. Book four is Java basics, and book five is untitled because I didn't supply any title. So you can have default and parameterized constructors like that. So let's talk about instance variables versus class variables. So instance variables are unique to each object, while class variables are shared across all objects. Instance variables are unique to each object, while class variables are shared across all objects. So let's see an example of that here. Imagine you create a class called company, and the company name is tech core. So that is class variable because it's not under what you have initialized as an instance. So this is actually a class variable because it is shared. So you can now use this company name everywhere in the class, right? But then when you initialize and you have employee name, so if you now say self.employee name equals employee name, that's the instance variable. So the instance variable is it's more like what we said the other time about global variables and local variables. So global variables are available everywhere in a module, in a Python module, whereas the local variable is only available to the function, right? So with this now, if you now have you have a company one, E1, which is a company, and the name of the name of the employee in that company is Alice. Okay, E1 is an employee of the particular company TechCore, which is Alice, and then you have E2 company Bob. So you want to find out what is the company, Bob's company, what is Alice's company. That's basically what this is about. All right. So if we run this now, it just tells us the two of them are from TechCore. Right. All right, because that's the it's a class variable. So all of them are automatically under that company, right? What else might we do with this? Yeah, I think that's it for this. Okay. Because you don't have any other function defined under this, so apart from the initialized one. So this initialization is automatic when you define a class. So the minimum you can have is you have a class and then you have the initialization, and that's it. Okay. Then of course you may want to you can have more things depending on what exactly you want to do. So let's talk about memory allocation differences. Now, instance variables are stored per object, while class variables are stored once for all objects. Okay. So if you're using class variables, they are stored once for all objects, but instance variables are stored per object. So imagine for this E1 up there now, okay, for this E1 up there, you now want to print E1 dot double underscore dict underscore double underscore. These are instance variables. But when you have print company dot double underscore dict double underscore, this is class attributes now. Okay, this is just for a particular instance because E1 is one employee of the company, but the company itself is the whole thing. So that's class attribute. So if you run this now, this is what you get. So E1 actually tells you about a particular employee, which is Alice. So Alice is an instance attribute, while the company tech code on its own is actually the class attribute because it is the whole class. That is the company right there. Of course, we want to do something like that again here, where we print another situation. Okay, I can do this. I just press tab. So tab, and then E2 now. So this first one is an instance, a particular employee of the company, while this other one talks about the whole company. So it's some kind of thing we are extracting from dictionaries in this case. So E2, Bob is an instance of the company, an employee in the company, while tech cost still remains the overall company itself. Then you have 12, 20, in the next one now, 26.2. So you saw we used double underscore dict, double underscore up here, and then we also have double underscore class, double underscore exploration. What do they do? So we have dict, which shows all attributes of an object, right? And we have class, which shows the class of an object, right? So here, if you have print A1 dict employee name Alice, then the class. So okay, then we run that and we have this. So it's more like a bit close to what we've been doing before. So if we go again and do print, all right, we do print and we okay, yeah, I was expecting this. Good. So we now do the same for E2 and this runs. Okay, this is not closed up. So we run this again. So we have Bob this time around. Okay, so let's see. Like I said, we'll be having mini projects after every video in object-oriented programming. So here, we want to do a student management system. The requirements, we want to create a student class with attributes name, age, and grade. And then we want to add methods like getInfo, which returns student details, and update grade, which tells us the new grade of the student that updates the grade. And number 3, we want to create multiple student objects and test, like we have different students like that, and we check them out like that. Okay, so imagine you create a class called student. So if you want to call the class, you need the student thing, and then they have 3 attributes: name, age, and grade. So we have self.name. Of course, this you already know the init thing already. Self.name is name, self.age is age, self.grade is grade. Then you have another function. So this is the initialization, which is necessary, but these ones are not necessary, but we need them. So we have defined getInfo. This is a new function you are defining. And what does this do? It returns the name. It says name is self name, whatever name you supply, then age, whatever age you supply, and the grade, whatever grade you supply. And then def upgrade underscore grade. What this actually does is that it takes the new grade, if you supply a new grade, and say self.grade, and then you have new is equal to new grade. And then you can now demonstrate with different students. So you have student 1, which is Alice, age is 20, grade is A, and you have student 2, Bob, 22, grade is B. So if you now print S1 getInfo, right? S1 getInfo is basically saying, tell us information about Alice. Then S2 dot update grade A plus. So it means that student S2 that had B before, upgrade the grade to this. By the time you now print S2.getInfo, the new grade becomes A plus automatically. So we run this now and we get Alice, age 20, grade A, and Bob now, age 22, grade A plus. So I can create just a new set of things. Let's create, say, student 2. Okay, let's create student 2. Okay, this is good. And then we create student 3. We create student 3. Okay, and that is okay, yeah, good. So we say, all right. So I use tab here. So because I don't want to see Bob all the time, let me do Donna, right? Or let me do Bendo, right? Bendo, and then this is Bendo again. Okay, so imagine, I think this doesn't quite work here. So I need a new student. So I want to create, let's say, okay, we have student 3. Student 3 had, okay, let's say this person had A star, if there's a grade like A star, all right? Then we now have student 3, let's say that student 3 is now crediting, right? Let's say student 3 is crediting is 27, and then the grade is A plus. Let's say the grade is A plus, and then we now found out something wrong with the grade, that the actual grade is A minus. So we have S3, and we update the grade to, all right, we update the grade to A minus, right? So in that case, if we print this one, it tells us the information, tells us Bendo 22 grade A star. Then student 3, right, is crediting age 27, grade A plus, and then we discover something is wrong. So we update the grade and if we get the info, it tells us the updated grade, not the initial grade. So here we have Pendo 22, grade A star, crediting age 27, grade A minus, because we've updated this grade. So you want to do your own management system, just to learn like that. So you can, try this out, or you can use, in fact, from this student management system, you can create some other system that may not be student management system. It can be hospital management system or something like that, so that you can try your hands on some of these things. So with this, I come to the end of this very interesting video. Thank you so much for listening. Let me know how helpful this video is for you. And if there's something you'd like me to try out, feel very free to let me know. If you have subscribed already, you are getting a lot. If you have not subscribed, you will be missing a lot. So go ahead, hit the notification, hit subscribe button, and of course, hit the notification bell so you can always get alerted each time a new video is released. You can take it a step further by actually joining. You can become a member of the channel and you get some special privileges, right? Ultimately, don't forget to like, share, and comment so that more people can have access to these videos so that they can learn a lot right here. All you need is your data and your time, and you're good to go. So feel free to avail yourself of this opportunity. Don't forget that you can get my code sheets by looking at the caption either on Facebook or on YouTube. You find a link to a Google Drive where you can get all these code sheets. So I always advise that you download first and follow step by step. So what I'm doing. So anything I do, pause, create a new cell, try it out, and that way you get to learn a lot. So come your way again, keep doing Python right. Bye.